Hey everyone! So in this video I'm going to continue our discussion of survey sampling, and specifically we're going to talk about an example of a survey in Afghanistan focused on civilian attitudes in the context of insurgency or civil wars and insurgencies, right? So opposed to a conventional war where two militaries ultimately are in conflict with each other, the situation in Afghanistan after 9/11 can be described as a counterinsurgency war. We have a military, mostly, but well, it's an international coalition led by the United States. And of course Afghan officials that are ultimately in conflict with insurgents, the Taliban, and of course these counterinsurgency wars are complex in the sense that, or more complex than conventional wars in many ways, because the key to victory is of course kind of not only winning militarily, but ultimately winning the sort of hearts and minds of civilians, right? So that means that aspects like aid provision, information campaigns, and minimizing civilian casualties, in principle, are crucial to kind of bring the population on your side, right? So obviously, in this context, it's kind of it's important to get an assessment of what the population in Afghanistan is ultimately thinking in different provinces, right? And so a group of social scientists conducted a couple of public opinion surveys in southern Afghanistan, which was kind of the hotspot of a lot of the insurgency, especially around the Helmand province, right here. And you see there's a map of Afghanistan, and we see a couple of pieces of information. We see districts that at the time were controlled. The survey was conducted in 2011 between January and February. Some regions like the Helmand province and other regions, other districts here, were at that time controlled by the Taliban. The red dots here are locations of violent events, and we have a couple of kind of contested districts and government-controlled districts. Okay. So a group of social scientists conducted this survey, ultimately focused on southern districts, southern regions in Afghanistan. They administered or they collected a sample of 2,754 respondents in 2011, and the participation rate in these surveys was actually incredibly high compared to our kind of phone traditional surveys in the US or in Europe. The participation rate was 89%, and so yeah, so that's incredibly high. But there are other aspects about the survey that ultimately make kind of inferences about broader populations a little bit more difficult. For example, due to kind of local culture, all respondents were male because the interviewers couldn't, the interviewers were prohibited to talking to female citizens, right? So this is only a sample, or the sampling population overall only includes male respondents. So this is the data overview. I include the data set as well as the code, as always, in our Studio Cloud. So if you jump in there, you can load the data and take a look at that right away. As you can see, we have so we're loading the data set using the read.csv command, and I'm just looking at the structure of this data frame. Just to get a brief overview, we have 2,754 observations with 11 variables, ranging from, for example, province, district, age of the respondent, education in years, employment, income, and importantly, we have here information on whether they experienced kind of violence or were subject to violence through the ISAF, so the International Security Forces, or subject to violence from the Taliban, right? And there's also a list experiment, and we're going to look at that later on as well. So as we look at these data, as I mentioned, there are a lot of potential issues with survey data because some respondents might not be willing to give certain answers to certain questions because they're sensitive. And ultimately, in R, these data, these observations or these individual data points that are missing have a special value in R. They are NAs, so they are. This is information that is not available, right? So whenever a respondent doesn't provide an answer, that's a missing value in R, and that is represented as an NA in R, right? And we have to be careful every time we kind of use survey data. We have to be careful how we handle these missing data, right? In many cases, when we want to compute, for example, the average, the mean of a variable, like the average age or average income and things like that, as soon as there are missing values in our data frame, or in that variable itself, then the resulting average that R gives us is missing as well, right? So if we look at now the average proportion, the proportion of people in the survey who experience violence, kind of was subject to violence, or had experienced violent experiences with the security forces, that is a missing because some respondents didn't provide an answer, so there are individual missing values, and so we can compute the overall mean when some of the individual values are actually not known, right? So in order to kind of ignore those missing values, we have to add an additional argument in our mean function in the function call, and that is the argument na.rm equals true. So that means we want to remove NAs, or the NA remove equals true, to say, okay, we want to ignore that there are some missing values, just give me the average for the remaining observations. And so if we include that argument, we see that 37% of the respondents had some experience of violent events with the international security forces. Another option is to use the NA omit function. In this case, we're basically including this NA omit command. The input to that function is the vector that is our outcome variable that we're interested in, and then compute the mean. That function is a little bit different, and I'll get to the differences in a second. But ultimately, at least for this case, it yields the same result. Ultimately, we're just dropping those observations from that vector and then computing the mean for the remaining observations. Okay. Whenever we're handling missing data in R, we have to be careful about how we want to kind of in what case we want to ignore observations and how many observations we want to ignore. And the key distinction here is between complete case analysis, or also known as listwise deletion, or available case analysis. Okay. So the underlying issue here is that, or the underlying distinction is, with the complete case analysis, we're basically kind of only focusing on observations that have no missing on any of the variables, right? And with the available case analysis, if we're looking at the average, for example, here the same outcome variable, we're only ignoring observations that have the missing values on that specific variable, right? So in most cases, even if there is a missing value on some variable, we still want to include that observation when we compute a mean on some other variable, right? So here, for example, this set of functions, is.na, basically turns the original variable into a vector of true and false outcomes. That is true if this function is na, if the variable is missing na, and false if it's not. And by summing them all together, then this true false vector is turned into a numeric 1, 0 vector. And so the sum of this command ultimately, or the sum of this vector ultimately gives us the number of missing cases on that specific variable, right? So 25 respondents did not provide an answer to this violent ISAF answer, right? Now, what happens if we just use the NA omit command on the entire data set, which we called Afghan? Then the number of observations is decreased much more. The reason why it's decreased much more is that this NA omit command omits all observations that have a missing value on any of the variables, right? So that's why it's called complete case analysis or listwise deletion of any observation that has some missing value on some variable, right? So obviously we're dropping more variables because it's not only the ones that have a missing value on the violent ISAF variable, but also missing values on the remaining variables, right? So if we go back, for example, or if we look at then the average of our outcome variable by kind of focusing only on the data frame that has only complete cases, we get a slightly different proportion of observations that kind of experience violence than in the previous case here, because we're dropping more observations that had missing values on other types of variables, right? So in most cases, you don't want to drop all the variables just because they have some missing value on some variable that you're not ultimately interested in, right? So this is kind of an example of where you ultimately drop more information than you would otherwise have to drop, okay? When you kind of want to get an idea of missing observations, you want to oftentimes include those missing observations as part of your contingency or frequency tables, right? So in general, if you, for example, look at the kind of the cross tabulation of whether people experience violence with the ISAF, the International Security Forces, or the Taliban, we can kind of look at the cross tab right here, but that will by default not show missing values. We can tell R to show us the missing values as well, and that can be informative in many cases. Unfortunately, the kind of argument here is a slightly different one. So with every different function, you kind of you have to look at the help file sometimes to kind of see how to treat missing values and what exactly, how to include them or exclude them. Here, the argument is not na.rm the same way it was with the mean function, but rather we have an argument called exclude, and if we include the option exclude equals null, then we actually include those missing values in our cross tab, right? So as I mentioned in the previous video, there are different sources of bias, like non-response, but there are other sources of bias. We talked about item non-response, where respondents kind of are not willing to answer a specific item rather than just not willing to answer the survey as a whole, which is the unit non-response. But ultimately, both, of course, can create bias. And how could this impact kind of inferences in our context, in the context of this specific survey of the Afghan population in the southern provinces? Of course, if we have more violent areas, then people might be less willing to respond to these surveys, right? So this is something we can kind of explore. Here we're just looking at the, again, is.na, and feel free when you kind of go through the code as I go through this in this video. If you look at the output of that kind of section of the command, it kind of turns the outcome variable, which is 0 or 1, into a logical vector, true and false, which is true in any case where there's a missing value on the original variable, right? So here we're computing the mean of the missing values, so the proportion of missing values across provinces, right? And so we see here that exactly what we kind of suspected, that violence is related to unit non-response or item non-response in this case, actually. We see that Helmand specifically, which of course saw a lot of violence, has a higher proportion, the highest proportion, or almost the highest proportion of unit non-response compared to, for example, Kunar and Logar, which had no non-response at all, right? So this is for the Taliban. We can look at the same with regard to violence in the context of the international security forces, and we see a similar pattern with high proportions of item non-response in Helmand and Uruzgan. Okay. So this is one example where we have potentially sensitive questions. Of course, those are Western interviewers who are asking about people's experiences with violence with, you know, Western international forces, and so there's, of course, that can be potentially sensitive, and of course there can be social desirability bias. There are other examples of social desirability bias in surveys in other contexts, like racial prejudice, corruption, but even turnout, right? If you ask people, did you participate in the last election, people tend to over-report how much they, and you know, one of our the first assignment that we worked on kind of showed this as well, that people over-report whether they voted or not compared to, you know, actual voting records, right? Another aspect that kind of makes this specifically or particularly important, or social desirability particularly pressing in the context of this specific data collection, was that the interviews were kind of held in public, right? So the interviewers walked around in these provinces, they talked to people, and ultimately, you know, they kind of held the interview, you know, in the open with other people around. So obviously there's even more social desirability bias in a context like that, right? So how do we, you know, how can we measure in a case like that where there is clear social desirability because of the context, the interviewer, also the fact that there are a lot of people around? One way, one technique to assess attitudes or opinions with sensitive content is a so-called list experiment. And I'm just going to go through the logic here real quick. Right. So the idea behind a list experiment is that rather than asking specific items, you provide people with a list of options and ask them about the number of items that they, for example, experience. Right. So, for example, here, people were interested in gathering support for the international security forces and the Taliban. Right. And so the list experiment starts with the following set of instructions. I'm going to read you a list with the names of different groups and individuals on it. After I read the entire list, I'd like you to tell me how many of these groups and individuals you broadly support, meaning that you generally agree with the goals and policies of the group or individual. Please don't tell me which ones you generally agree with, only tell me how many groups or individuals you broadly support, right? And so the key here is that in the control group, we have a list of kind of relatively less sensitive groups. So for example, we have the at that time Karzai government, National Solidarity Program, and local farmers, right? And then we have, and that's the control group. And then we have a treatment group where some respondents that were randomly assigned to this treatment group received an additional option where we had either the international security forces or the Taliban, right? So essentially two different treatment groups, right? And so none of the respondents had to say whether they supported the Taliban or the ISAF. But what they did was they said how many of these groups do they generally support or not, right? And so then based on the numbers that you receive in each of these groups, and by comparing the control group and the treatment group, you can get an assessment of how many people support the Taliban or the international forces by kind of just comparing the difference in the treatment and control group, for example, by region. So that allows you to get an estimate of support for the Taliban and the international forces by region without bringing respondents in the problematic situation where they kind of have to admit to the interviewer that they support one or the other. So how would we want to analyze this in our context here? We can look at the first we can just look at the proportion of those who support the international forces by basically looking at the average number that respondents gave in the ISAF group versus the control group. And so that's the difference. That's the difference in how many groups they supported in each of those treatment and control groups. And that gives you an estimate of the proportion of those who supported the ISAF, and that's why they provided a larger number in the treatment group. Of course, there are problems with that as soon as you have floor and ceiling effects, which is basically if you're saying that I support none of the groups or if I support all of the groups, ultimately that kind of destroys this kind of plausible deniability and kind of reveals your preferences immediately, right? So one question or one problem in designing these list experiments is to come up with a list where it's very unlikely that someone would say yes or no to all of those options, right? So in the context of, if we look at the kind of frequency table for response options here, we see, of course, in the control group, no one said 4 because ISAF and Taliban were not included. And we had actually, when the ISAF was included, 24 respondents, kind of a ceiling effect where they said, okay, I support all of those. And with the Taliban, and at the same time, 174 kind of revealing that they didn't support ISAF because they said, oh, I don't support any of those groups, right? So if you have cases like that, that's potentially problematic because it defeats the purpose of this list experiment because it reveals the preferences, the true preferences of individual respondents. All right, so that was a cool, interesting example. I encourage you to kind of look at those data a little bit more. We'll look at it a little bit more in the next video as well, where we're going to talk about visualizing distributions.